This video is on addition reactions for alkenes and alkynes. So addition reactions are the dominant reactions for any alkene and alkyne. This means that it's the addition of something to the two atoms that form the double bond. So the atoms on either side of that double bond, the double bond will break, and those atoms, those carbons in this case, will bond with whatever you're adding. So for example, an addition reaction of a halogen to ethylene, so halogens, right, fluorine, chlorine, bromine, iodine. Ethylene is a common name for ethene. It's just a little easier to say. So that's what we have here. This right here, this is ethene or ethylene, right? And if we add bromine to it, that means we're going to have this double bond right here that breaks. So what you're going to get is you're going to get that carbon, right? Carbon. Here's the two hydrogens on each of them. All right, and they each have that single electron that was in the double bond. So now what's going to react there or bond there is a bromine on each of these. Okay, so this is an example of an addition reaction. So this can happen with a lot of things. It doesn't have to be just a halogen. So it can happen with hydrogens. This is called hydrogenation. This happens in industry and in foods. Hydrogenation, you're adding hydrogen. So you're going from what's called an unsaturated molecule to a saturated molecule. This requires high temperatures and pressures, and then it also requires a catalyst. So it takes an alkene, like we just saw, and it turns it into an alkane because instead of adding bromine, it's adding hydrogen. An alkyne could be converted to an alkene. So an example would be if I had butene right here, specifically, right? I have 2-butene. Right? And I'm going to add hydrogen to it, right? So I'm going to have a nickel catalyst in this case. I'm going to have a high temperature. So I'm taking this molecule that is saturated, unsaturated, meaning, right? I'm not going to draw my H's, but I'll draw the lines for them. C double bond C, could be cis, it could be trans. That's not important right now, but this right here is unsaturated, right? Saturated means like full. Unsaturated means it's not full, right? You've got like bonds right here that are bonded to carbons instead of being bonded to hydrogens. So saturated means it has all single bonds. It's an alkane, which is what's going to happen. This is going to turn into, right, your carbon with 3 hydrogens. That carbon-carbon double bond is now a single bond, and you're going to have hydrogens where that double bond was. So you're going to go from 2-butene to butane. That's hydrogenation. So other things you can add besides just halogens or just hydrogens is you can have a combination of a halogen and a hydrogen, or you can have water that can break up that double bond. So for example, ethene right here, if I add HBr, you're going to turn this into, right? You're going to have carbon with your 2 H's that are already there to carbon with that one's 2 H's. And you're going to get an H where the double bond was and whatever your halogen is, bromine in this case. So you're going to turn this from ethene to bromoethane. Okay, another example would be if we add water. You're again going to have that carbon-carbon double bond turns into a single bond. They both already had hydrogens. And now, where that double bond was, you're going to have a hydrogen on one and a hydroxide on the other. And we haven't talked about naming with functional groups, but this functional group, I hope you recognize it as an alcohol, right? Or a hydroxyl is the functional group. Alcohol is the class. Alcohols change the ending from ane to OL. So this is ethanol. Okay. So, for example, a question could come up, what's the product of the hydrogenation of 3-methyl-1-pentene? So here's where I would draw my 3-methyl-1-pentene first. So I'm just going to kind of draw it condensed. H2C double bonded to CH to CH. This is my third carbon then, so this would be my methyl group, right? 3-methyl. And then CH2, CH3. All right, hydrogenation means I'm adding hydrogen. There's going to be some sort of catalyst, okay? And that double bond is going to break, right here, and it's going to be replaced with hydrogen. So I'm going to make, and I'll have to draw it down here, H3C, right? And everything's going to have single bonds, CH2, CH, and then there's my methyl group still, that hasn't changed. And then CH2, CH3. All right. So last part of this is we can use this as a test for alkenes. So if we have a solution and we need to know if it's an alkene versus an alkane, we can add, the test is to add bromine water. Right? So if we just add bromine, right? So this would be a Br2. Okay, if it's an alkene, it's going to react. So an alkene will react. An alkane no reaction, right? An alkane is saturated. It's filled up. If it's unsaturated, an alkene or an alkyne even, it would react. And how we know that is there's a color change. Bromine water is a brown red color. Okay, so if it reacts, there will be a color change. If it doesn't react, there will be no color change. No color change. All right, so any alkene with bromine water. For example, let's say we just have cyclohexane. Right, all single bonds, okay? We have bromine water to this. So this Br2 is that brown red. This is gonna be no reaction because we don't have any double bonds to break up where the bromine can go. There's nowhere for it to go. Whereas if we have an alkene, so let's say we have that cyclohexane and we turn it into cyclohexene, so we've got a double bond in one spot. This is colorless. Let's add that bromine water, which is that brown red. Okay, and that bromine is now going to bond where that double bond was. Right, so we're gonna have a bromine here and a bromine here. And this is going to be what they say is decolorized. Okay, it's not necessarily gonna go colorless, but it will not be this brown red. And I will show you a video of this so you can see what this looks like. So this is a test to see if something has a double bond or just single bonds, right? This is adding bromine water. And that is addition reactions for alkenes and alkynes.